Alright, the purpose of this video is to go over our first test so that you can make corrections on anything that you missed. You can fast forward to any of the problems that you need to see. If you need to rewind to look at a problem again to make sure you understand what to do to get the correct answer, you can do that. And then our corrections will be then turned in tomorrow, hopefully. So I'm just going to go over them one at a time so that you can follow along. So number one first, write a recursive formula for this sequence. Remember, a recursive formula is always based on the previous term. So to get a sub n, we're going to take a sub n minus 1, which is the previous term, and we're going to add, in this case, the common difference, and the common difference is 6. So we will add 6. And then when it says find the next term, we're going to take 29 plus 6, which is 35. So that's what you should have for number one. Number two, write a recursive formula for this sequence. Now this sequence is a little bit different. It's not geometric and it's not arithmetic. But it's a recursive formula, which means we have to figure out what do we do to 15 to get 29, and 29 to get 58, and 58 to get 113. The way that most people did this, which is a good way to do it, is if you double 15 you get 30, but 29 is one less than that. If you double 29 you get 58, but 57 is one less than that. 57 doubled is 114, but 113 is one less than that. So you could do this. In order to find a sub n, you could take the previous term, which is a sub n minus 1, multiply it times 2, and then subtract 1. That's one way to do it. There are other ways that people found in order to do that, but this is probably the one that was used the most often. And then to find the next term, we would take 225 and double it, which is 250, minus 1, or 450, and then minus 1, which is 449. These are both worth 4 points apiece, 1 and 2. If we move on to number 3, write an explicit formula for this sequence. Looks like we subtract 2 each time, or we could say we add a negative 2. So with this one, an explicit formula, we start with the first term, which is 6. We're going to subtract 2 n minus 1 number of times. You could start with 8 and then subtract 2 n number of times, and that would also work. But then to find the 14th term, I'm going to take plug 14 in for n. 14 minus 1 is 13. And then 2 times 13 is 26, and 6 minus 26 is negative 20. So the 14th term is negative 20. Number 4, find the 60th term of that sequence. So it looks like we're subtracting 7 each time. So we could write an explicit formula for this, and the explicit formula would look something like this. We have 5, and then we're subtracting 7, n minus 1 number of times. So we would actually plug in 60. We would take 60 minus 1, which is 59, 59 times 7, and then 5 minus whatever we get, and that is negative 408 for number 4. Find the missing term. Number 5, find the missing term of the arithmetic sequence. If it's arithmetic, then we're going to find the arithmetic mean, which means we add them together and divide by 2. So we're basically is taking the average. 30 plus 36 is 66 divided by 2 is 33. So the arithmetic mean is 33. Number 6, it says the Homestead cheer block makes a human pyramid with 15 people on the base of the triangle and 1 person on the top. How many people are needed to make the pyramid? So we have 15 people on the base row and then 14 people, 13 people. So basically we're adding, the top row would be 1 person, 2 people in the second row, 3 people on the third row, all the way up to the 15th row, which is 15. We're adding these numbers together. So we're going to take the first term plus the last term. That's 1 plus 15. And then we're going to take the number of terms, which in this case is 15 divided by 2. That's 7.5 times 16, which is 120 people. And that's number 6. If we move on to second page, number 7. Number 7, is this sequence geometric? And it looks like we multiply by 3, and then we multiply by 4, 24 times something else is 54, so we're not multiplying by the same thing each time, so this is just, no, it is not geometric. We take a look at number 8, write an explicit formula for this sequence, and then find the 13th term. So they gave us the first term is -4, and then we're going to be multiplying by the common ratio, which in this case is -2 to the n minus 1 power, and that is the explicit formula. And then when it says find the 13th term, we would plug in 13 for n, which means we're going to take -2 to the 12th power times -4, and that gives us negative 16,384. So the -2 to the 12th power is positive, but then when we multiply it times -4, we get a negative number here. So some of us had a positive 16,384. It should be negative. So number 9, find the missing term of this geometric sequence. Well, that's when we multiply the two terms together. We take 53 times 1,325 and then take the square root, and that's 265. Moving on to number 10. Using this finite sequence, write the related series. The related series, and it was originally 4 points for this whole thing. By the way, everything up until this point has been 4 points per problem. So this is 4 points, but what I really wanted on this line, and I didn't take off points for this, is 25 plus 29 plus 33. The related series is just the same numbers, basically with just plus signs, like it was on your homework. And so that's what the related series would look like. And then when it says evaluate the series, we basically want to add all these numbers together. So it is arithmetic because we're adding 4 each time. So we're going to take the first term, which is 25, plus the last term, which is 49. There are 7 terms, so we take 7 divided by 2, and then times 25 plus 49. And that gives us 259 if we add all those numbers together. Number 11, the sequence -5, 0, 5, 10. Looks like we're adding 5 each time. It has 35 terms. When it says evaluate, we are evaluate the related series. That means we are going to be adding them all together. And again, the first term is -5. The last term, we don't really know. We know that there are 35 terms, so we divide that by 2. So what we have to find first, in order to do number 11, is we have to find the 35th term. Well, if we start with an explicit formula here, that means we start with -5 and we add 5 n minus 1 number of times. And if we plug a 35 in for the n, we're going to take 5 times 34 plus -5, and that gives us 165. That's the last term in the sequence. So to find the sum, we take the first term plus the last term, that's -5 plus 165, and then times 35 over 2. And that is 2,800. Number 12. What they want us to do on number 12 is just use summation notation to write this series. So they said it has 11 terms, so we're going to go from 1 to 11. And then we're going to write an explicit formula here. The explicit formula for this, we start with the a sub 1, which is 47. It looks like we subtract 5 n minus 1 number of times. So that's what we would do for number 12. Number 13, for this series, find the number of terms in the series. Well, the number of terms is going to be 5 minus 2. 5 minus 2 is 3, and then we always add 1. So the number of terms is 4. Number 14, for the series, for this series, find the first and the last term. Well, the first term is going to be when I plug in a 1. 1 minus 3 is -2. The last term I would get when I plug in a 4. 4 minus 3 is 1. So number 13 was worth 3 points. Number 14 was worth 4 points. And then the last one on this page, number 15, is also worth 4 points. It says evaluate this series. If I were to plug in a 3, the first term that I'm going to include is 15, because 5 times 3 is 15. Then I would plug in a 4 and get 20. Then I would plug in a 5 and get 25. So you can see this is arithmetic. So we're going to use this formula, the number of terms over 2, and then the first term plus the last term. To find the number of terms, I'm going to take 27 minus 3, which is 24, but then I add 1, so that's 25 terms, 25 over 2. The first term is 15, and the last term I would get when I plug in a 27. 27 times 5 is 135. So if I take 135 plus 15 and then multiply that times 12 and a half, I get 1,875. And that's what you should have for number 15. We move on to number 16 on your test. It's on the next page. Hopefully you can see this. I don't know how clear this video is coming out, but number 16, Justine earned $18,000 on her first year on her job. So she made $18,000. After each year, she received a 2% raise. That means we're going to multiply by 1.02. She gets 100% of what she made the previous year plus 2% more. So that's the ratio that we're multiplying by. Her total earnings for the first 14 years, we're going to use this formula. A sub 1 times 1 minus r to the nth power over 1 minus r. First term, A sub 1 is 18,000 times 1 minus the ratio, which is 1.02. The n is 14 because there are 14 terms over 1 minus 1.02. And if we calculate that correctly, we should get that she earned a total of $287,530.89 over those 14 years. Number 17, a rubber band or a rubber ball dropped from a hard surface takes a sequence of bounces, each 3/5 of as high as the previous bounce. So the first bounce comes down 10 feet. If the ball is dropped from a height of 10 feet, what is the total vertical distance it travels after it has hit the surface the 5th time? So it comes up. A lot of us figured out that we'd multiply by 0.6. That's 3/5. So we multiply by 0.5. It comes up 6 feet then, and it goes down 6 feet. And then I think it was 3.6 and down 3.6. So here it hits the surface the first time, the second time, the third time, the fourth time, and then the 5th time it stops. So we want to know what is that total distance. There are several ways to do this, but one way to do this is to use the same formula we used in number 16. The first term in the sequence is 10. We're going to multiply that by 1 minus the ratio, which is 0.6. It falls 1, 2, 3, 4, 5 times. So to the 5th power over 1 minus 0.6. Now this isn't the whole thing. This is just part of it. This is the distance it travels down. But then it also goes up. But the first time it goes up, it only goes 6 feet. So the initial term is 6. We're going to multiply that by 1 minus 0.6. But this time only to the 4th power because it only goes up 1, 2, 3, 4 times over 1 minus 0.6. And this is how far it goes up. And then if we add those two things together, I think this is 23 point something, this is 13 or 12 point something. When we add them together, we get 36.112 is the total vertical distance, including the up and the down distances. So move on to number 18. Does the infinite geometric series diverge or converge? And we can see that it's getting smaller. 1/6 gets smaller to 1/3. As a matter of fact, we multiply by 1/5 each time. 1 over 30 times 1/5 is 1 over 150. And if we keep multiplying by 1/5, that's the ratio. So it does converge. And because it does converge, we are going to be able to find a sum. But it goes on indefinitely. So now we're just going to use this formula, a sub 1 over 1 minus r. First term, a sub 1 is 1/6 over 1 minus a 5th. That's the same thing as 1/6 divided by 4/5. You can write down 5 over 24, which is 0.0283, repeating. By the way, 1/6, 1 minus 1/5 is 4/5. So we're taking 1/6 divided by 4/5, which is the same thing as multiplying by 5/4. And so some people just wrote it down as 5 over 24, which is fine. Number 19, evaluate this infinite geometric series and round to the nearest hundredth if necessary. We are not multiplying by 3, we're multiplying by 1/3 here. 27 times 1/3 is 9. 9 times 1/3 is 3. So we're going to use this same formula that we used in number 18. The first term is 27 over, and then 1 minus the ratio, that's 1 minus 1/3. Well, that's 2/3. And 27 divided by 2/3 is the same thing as multiplying by 3/2, and that comes out to 40.5. 16 and 17 are worth 5 points apiece. 18 and 19 are worth 4 points apiece. Now on the back of this sheet, starting with number 20, consider this infinite geometric series. Write the first 4 terms of the series. So we're going to find the first term by plugging in a 1. 1 minus 1 is 0. 1/3 to the 0 power is just 1. So the first term is just going to be -4. Then if I plug in a 2, I'll get -1.3 repeating. If I plug in a 3, -0.4 repeating. And then the fourth one is -0.148. And those are the first 4 terms. Does it diverge or converge? Well, it converges because the numbers are getting smaller, closer to 0. So it will be a graph that looks something like this. As it approaches 0, it will never touch 0, but it'll get closer and closer to it. And then because it converges, we can evaluate it. We're going to take the first term, which is -4, over 1 minus the ratio, and the ratio is 1/3. So -4 over 2/3, which is the same thing as -4 times 3/2 is -6. This is worth 2 points, this is worth 2 points, and this is worth evaluating. It was actually worth 4 points. Move on to number 21. Yvette is creating a design in which she draws squares within squares as shown. She begins with a square having a perimeter of 12 inches. Each inner square has a perimeter that is 85% of the original square. So the outside square has a perimeter of 12. Then we're going to multiply that by 0.85 to figure out what the perimeter is of the next square. It's 85% of the previous square. And so we want to know what the sum is if it went on indefinitely. So again, we're going to take the first term, a sub 1, which is 12, over 1 minus the ratio, which is 0.85. And that is 80. That was worth 5 points altogether. Last question then, number 22. Consider this sequence. -7, -5.6, -4.2, and so on. It looks like we are adding 1.4 each time. We're adding 1.4. So the explicit formula is going to be the first term, which is -7. We're going to add 1.4 n minus 1 number of times. That's how you find a sub n. The recursive formula is this. You always find each term by taking the previous term and adding the common difference, which is 1.4. And if we want to find the 50th term, we want to use the explicit formula, because all we would have to do then is plug in 50 for n. And if we do that, we're going to take 50. We could take 50 minus 1 times 1.4 and then add -7. So we'd use the explicit formula, but then they want to know which term is 103.6. So at some point on this sequence, there would be 103.6. And we want to know what term number that would be. Well, the explicit formula is -7 plus 1.4 to the n minus 1. And eventually that is going to give us a 103.6. So there's several ways to solve this equation, solve this problem here, but we can add 7 to both sides and distribute the 1.4, which means we'd have to add 1.4 again and then divide by 1.4. If we solve that equation correctly, we should get that it is the 80th. N is 80, which means 103.6 is the 80th term in that sequence. Hopefully what we did, this video is able to do, is allow you to see some of the mistakes that maybe you made during the quiz or during the test. Hopefully you can fix those mistakes on your correction sheet and come to class not only knowing what you, how to do each problem correctly, but knowing what it was that you messed up on when you took this test the first time. So we are going to be moving on to Chapter 2 then, and we'll see you tomorrow in class.